All right, so these are solving linear equations that are algebraic in nature. So there's stuff from Math 80. We have our basic equation here, and we have some rational functions as well. So if you remember, we have our basic steps. We want to simplify, so distribute and multiply, combine like terms, remove fractions, trying to get it down to our basic equation. So if we distribute this negative 5w minus 7w plus 4 minus 2, combine like terms, do the same thing over here. What we get is our nice basic equation. Everything that can be added or subtracted on each side, multiplied or divided, has been done. Now we can solve. So we need to pick a side. I'm going to move everything over to this side for the w's. Anything that's not a w, I move to the other side. So this way I get w's on one side, non-w's on the other, and there is my answer. And these can be checked in Desmos. So what we're looking to see is when does this one equal, this left side equal the right side. So if you input those two equations in Desmos, where they intersect is our answer. So when x is equal to 1, you have to use x, by the way, you can't use w, whatever letters applied. But yeah, our x here, these two are going to be equal to 0 when x is 1. And what answer do we get? 1. So plug the left side in, plug the right side in, and they will work the same way. All right, so let's try the next one. So on this one, we have fractions. So to remove fractions, you want to multiply both sides by the LCD. So we have a 3, an x, a 2, a 3, and an x. So 6 and x is our common denominator. The 6 will get rid of the 3 and the 2, and the x will get rid of the x. We're going to distribute it. So this will mean that we're going to multiply each one of these by 6x. Since I have 4 terms, I'm writing a 6x 4 times. This would be 2 over 3x plus 1/2 equals 4 over x. The dotted line just represents the equation, the equal sign. All right, and then now with a nice little simplifying, the 3 and the x will cancel, giving us 2. 2 times 2 is 4. So by doing this, we turn our equation from a rational into an exponential. So that would now be 3 into a linear, not exponential. That x cancels the x, and we get 24. And you can relax because we know Desmos, or any graphing calculator, will check it for us. So cancel the 3, so 2. So 2 times 4, so that's 8x. And there is our nice linear equation. So now we can solve it. Minus 4x, minus 4x. Minus 3x, minus 3x. And so now this is our non-x side, so minus 24, minus 24. And that gives us negative 20 equals 5x divided by 5, divided by 5. X is equal to negative 4. So now we will open Desmos and plug them in. Okay, so they are plugged in, and there's our rational functions that we know they would look like. And look, that's where they cross. By the way, if you're still having issues with fractions, all you have to do is use the division sign for divided by, and then you can put a 2 and an x down there, and then scroll out to get out of it. But yeah, there's our answer. Negative 4 is when they're both equal to, that is our x value. And that is what we got, x equals negative 4. All right, let's try one more. So here, our LCD would be the x plus 4. And to save a little time, I'm just going to parenthesis each part this time. This way I get everything. And the x plus 4 will then cancel, leaving us with 2x on the left side. 7 times x plus 4 minus 6. Nice linear equation. So we still need to distribute because that is one of our rules for simplifying. Everything needs to be fully simplified before we actually start solving. We are not solving yet. We are just simplifying. Okay, now I cannot add any more, do anything else. Now I can solve. So minus 7x minus 7x It's negative 5x equals, wrong color, negative 5x equals 22. Divide by negative 5, divide by negative 5, x equals negative 22 over 5. You can also write this as a decimal, and that would be 4.4. Your choice. And we're going to check in Desmos now. And so in Desmos, you have these two rationals. If you click on these, you'll see they just don't cross. They give you the intercepts just like before. But clicking on this one, oh, there it is. So negative 4.4, which is what the answer we had. And again, if you need to, another way to do fractions, if you just hit the division sign, it makes the fraction. And then you can click and put anything you want, top and bottom that way. There are two, negative 4.4 check. So there's no reason to get any of these wrong. Well, I guess not doing them correctly, but checking them, you should be able to check as you move. Okay. So these are now complicated. If you look at the left side and you look at the right side, these are not easy to solve in the form they are, and sometimes they're impossible. So we're going to do it two different ways. We're going to do the left and the right, just like we've been doing with Desmos. So you're going to enter this as the left, and this is the right. And you're going to input them in the calculator and try to find their points of intersection. So we'll do one together, and then you'll try this one. And then we're going to also try it as a zero command. There's two different ways of doing this. So we're going to input the left into Desmos, and then the right into Desmos. So 0.2 x to the fourth plus x cubed. So 0.2 x, and then the power key is here. You put a 4, scroll out, plus x cubed. Same thing, power key, cube, and we're done. Now the right side, that's 1/2 x plus 2. So 1 divided by 2, you got to scroll out, x plus 4, plus 2. Easy to fix, plus 2. And then now we look for the point of intersection. Right there and right there. So that one right there is a 0. You can tell that's a 0 because it's a 0. We don't want that one. We want the one right below it. You can even zoom in if you need to grab it better. But those are our answers. Negative 4.98 and 1.281. So negative 4.98. X equals negative 4.98, and x equals 1.281. Okay, I was going to have you input this yourself, but I realized I haven't shown you how to do these yet. So to put in this, there is no cube root. What you have to use is the root as a rational exponent. So if it's a cube root, you write 1/3, and so that will now work. So we have parenthesis x plus x squared plus 2 x squared plus 2, close the parenthesis, and then use the exponent key here and put 1 divided by 3. So now that is our cube root. Now the other side is 2x to the fourth. Scroll out. Minus 7x squared plus 11. Okay, and now if you look at these, look, they don't intersect. And we know these are our cube roots. They're going out to the side like that. He's not coming back around. It's a function, and this is our degree 4, so we know it's going up like that. It's a parabolic type shape. So if they don't intersect, that means what we have here is no solution. It is possible that these are never equal. So there's your two answers. You're either going to get two answers because they intersect, or you won't because they don't. Okay. This is how you do it as a zero function. So you're going to enter and move everything over to the left. So I've subtracted the 1/2 x over and the 2 over, and we end up with this for our left side now. And this just has to equal 0. So what this means is we're looking for the zeros, the x-intercepts. Okay, so you're going to enter that entire thing on the left. like this. So all as 1. And so what you end up with now, clicking on it, is the zeros, your x-intercepts. Those are your answers. You don't have to look for an intersection. You don't have to look for 2 different graphs. It's just 1. So if you move everything over to the left, even everything over to the right, it works the same way. So let's look at this one. So I've moved the 2x over, the 7x became a positive, and the 11 became a negative. Everything changes signs. So now when we do this one, we end up with this, and you see that there are no zeros. This will never hit 0. So for our equation saying when does this equal 0, it doesn't. So we can also again say no solution. So this is another way to do it. You can use the zeros, just plugging it in that way. All right, thank you.